what is strictly feasible, because in this latter theorem we say well, if it is strictly feasible, then you find if it is strictly feasible, B star equal D star, and so you have strong duality as you want, but how can we prove it is strictly feasible? So strictly feasible is just to say that this, like all eigenvalues are strictly superior to 0 instead of this. So yes, no, like just feasible only. But yeah, let's go through an example. So let's take the standard form that we saw a lot of time now. Sub of x of trace of say x such that uh, trace of fa of x is inferior to ai, and x superior to 0, and to make it positive definite. And so if we take, for example, identity, which is a real trick, like because it works a lot of time, because it's a semi-positive, like we know this is strictly, like it's strictly feasible in a way. I mean, which is positive, because if you take like the stuff, it's 1 minus lambda squared if you take the determinant. And so it means that lambda equal 1, because lambda 1 equal lambda. So yeah, I mean, just like lambda square minus 2 lambda plus 1 equals 0. And so yeah, just 1 minus lambda by 1 minus lambda equals 0. And so you have those two equations to solve, and you see you have lambda 1 equal 1, and lambda 2 equal 2. Lambda 1 equal 1, and lambda 2 equal 1. And so yeah, you have this, and just to try to demonstrate it, you take, so x is equal to y, and so you try to verify the constraints, so the trace of fi, and so of fi x is equal to it. So yeah, you fix also, for example, fi equal identity 2. So you just have the trace of I multiplied by I. It just, like I said, the stuff, but I squared is I. And so the trace of, and you fix b equal to, I mean, you fix a. We know for now it will be like a1 equal 2, f1 equal, like I equal f1. So the trace of f1 of x is equal to trace of y, I squared is just I, and so the trace of I, you know, so just diagonal the trace, so it's 1 plus 1, so it's 2. And so because we fixed a2 is 2, so we have 2 is equal to 2. I mean, 2 is really is inferior to 2, so it's right, it's okay. And so because we find a matrix x equal y which respects equality and which is positive, no value proper eigenvalues that are 0 but always superior, you just find a strictly feasible problem like x equal y respects equality, respects constraints, if you prefer. So 2 is inferior to 2, okay, and 2. So this and this, and because I is positive, like no eigenvalues, like I don't know if it's the right term this, but eigenvalues strictly superior to 0, because the eigenvalues are strictly superior to 0, because it has those two conditions, then those two conditions imply that our problem our primal, if you want, is strictly feasible.